Have you ever wondered how electricity actually works, or why we need resistors when working with LEDs? In this video, we'll break down the very fundamentals of electronics in a way anyone can understand. You'll finally grasp what voltage, current, and resistance are, and more importantly, how they work together to power your Arduino projects. By the end of this lesson, you'll build your first LED circuit using resistor, jumper wires, and a breadboard, and you'll know exactly why each component matters. If you are new here, welcome! This is the fourth video in a 24-part series called Arduino for Beginners. In the last few videos, we explored what Arduino is and how to get started. Now, we take our first real steps into the fascinating world of electronics. Let's start from the very beginning. What is electricity? Everything around us is made of atoms, and atoms are made of three main particles: protons, neutrons, and electrons. The protons and neutrons live in the nucleus, while the electrons orbit around them in what is called the electron cloud. In electronics, we mostly care about the electrons because they can move. When electrons move from one atom to another, that movement is called electric current. But electrons don't just move on their own, they need a push. That push is called voltage. It's the force that moves electrons through a material. Let's imagine a battery. It has two sides, one full of electrons, negative, and one with fewer electrons, positive. If we connect both sides using a copper wire, which is a good conductor, electrons will flow from negative to positive. That's current. But if we try the same thing using a plastic wire, nothing happens. That's because plastic is an insulator. It resists the flow of electrons. And this brings us to our third concept, resistance. Some materials allow electrons to flow easily, like copper or aluminum. Others resist that flow, like plastic, rubber, or even air. A resistance is simply how much a material opposes the movement of electrons. In the 1800s, a scientist named George Ohm discovered a relationship between these three things: voltage, current, and resistance. That relationship is known as Ohm's law. Voltage equals to current times resistance. This means if you increase voltage while keeping resistance constant, more current flows. If resistance goes up and voltage stays the same, current goes down. You can think of voltage as water pressure, current as the flow of water, and resistance as a narrow pipe that restricts the flow. That's the core of electronics. Now, before we go further, a quick thank you to our sponsor, GF Robot. They provided us with the Mind Plus Arduino coding kit, which we will be using throughout this course. This kit includes sensors, buttons, LEDs, and everything else we need to build awesome projects. It's perfect for beginners and I highly recommend it. Let's take a look at some of the basic electronic components we'll be using today. Number 1. LED, a light emitting diode. It lights up when current flows through it in the correct direction. LEDs are polarized, meaning they have a positive anode and negative cathode side. The longer leg is the positive one. Number 2. Jumper wires, small wires used to connect components on a breadboard. You'll find male to male, male to female, and female to female types. Number 3. Resistor. Resistors limit current and control voltage in a circuit. They protect components like LEDs from receiving too much current. Number 4. Breadboard, a solderless prototyping board. You insert components and wires into holes that are electrically connected inside. Rows in the middle are connected vertically. Power rails on the sides are connected horizontally. Now that we discussed the components, let's take a closer look at resistors. Resistors are essential components that help us control current flow. They have two important characteristics. Number 1. Resistance value in ohms. This tells you how much the resistor resists current. Number 2. Tolerance indicates how accurate the resistance value is. For example, a 220 ohm resistor with 5% tolerance could actually measure anywhere between 209 and 231. Most resistors use a color code to indicate their value. The colored bands represent digits, a multiplier, and sometimes tolerance. There are two common types: 4-band and 5-band resistors. 4-band resistors. First band means first digit, second band means second digit, third band means multiplier, and the fourth band means tolerance. For example, a resistor with red, brown, gold means 2 times 10 and a tolerance of 5%. This is a 221 resistor with a 5% tolerance. Now the 5-band resistors. First band, first digit, second band, second digit, third band, third digit, fourth band, the multiplier, and the fifth band, tolerance. For example, a resistor with brown, black, red, brown means 100 times 100 with a tolerance of 1%. This is a 10k ohm resistor or 10,000 ohm resistor with 1% tolerance. Now that you understand a lot about resistors, let's discuss why they are important for any circuit. Resistors are essential in electronics because they regulate the flow of electrical current, protecting sensitive components from damage. But their role goes beyond just limiting current. They are also used to divide voltage, control signal levels, and safely dissipate excess power. In almost any circuit that includes LEDs, resistors are essential. That's because LEDs have a very low internal resistance and are sensitive to high current. If you connect an LED directly to a battery, it may draw too much current and burn out almost instantly. To prevent this, we place a resistor in series with the LED, usually on the positive anode side, to limit the amount of current flowing through it. Let's look at an example to calculate the appropriate resistor value. Suppose we are connecting an LED to a 9-volt battery and the manufacturer says the LED operates best at 50 mA. Using Ohm's law, voltage equals to current times resistance. 9 equals 0.05 times resistance. So we know that resistance is equal to 180 ohms. So we need a resistor of about 180 ohms. If that exact value isn't available, we'll use the closest standard resistor, like 220 ohms. That's why we use a 220 ohm resistor in our project. It still limits the current enough to protect the LED while allowing it to shine properly. Now that we went through all this theory, let's get our hands dirty. We are going to build a light sequence using 8 LEDs connected to the Arduino. These LEDs will blink in pairs, starting from the center and moving towards the edges, then back to the center, like a ripple effect going out and in. First, LEDs on pins 5 and 6 turn on, then pins 4 and 7, then 3 and 8, finally 2 and 9. After that, it reverses 3 and 8, 4 and 7, and finally back to 5 and 6. Only 2 LEDs will be on at a time, and each pair will stay lit for a quarter of a second. After that, they will turn off and move to the next step in the sequence, and the process repeats forever. For this project, you need Arduino board, breadboard, 8 LEDs, 8 resistors, 220 ohms, jumper wires. After you get the components, assemble them like this. Insert the 8 LEDs into the breadboard in a row. Make sure the long legs anodes are on the same side. Connect a 220 ohm resistor to the anode of each LED. Use jumper wires to connect the other side of each resistor to pins 2 through 9 on the Arduino. Each pin should connect to one LED. Connect the cathode short legs of all LEDs to the G&D rail on the breadboard. Finally, connect the G&D rail of the breadboard to one of the G&D pins of the Arduino. Double check your wiring according to these schematics. When you upload the code, you'll see the LEDs blink in a mirrored pattern. starting from the middle, LEDs pins 5 and 6, moving outward to the edges, pins 2 and 9, and then reversing back to the center. This ripple-like effect repeats continuously, with only 2 LEDs turned on at a time for 250 milliseconds each. If you'd like to download the code, it's available on the GitHub repository for this Arduino for Beginners series. You'll find the link in the video description below. Here's what the code is doing. First, it sets each of the LED pins 2 through 9 as output. Then, in the loop function, it turns on 2 LEDs at a time in a specific mirrored order, starting from the center and moving them back inward, with short delays in between to control the timing. Each pair of LEDs is turned off before the next pair is turned on. If you are having trouble understanding the code or uploading to your Arduino board, don't worry. Make sure you watch the first 3 lessons of this series. In those videos, I walk you through how to set up the Arduino IDE on your computer, how to connect your board, and how basic commands like pin mode, digital write, and delay work. That foundational knowledge will make everything in this lesson much easier to follow. If you are using Mind+, you can create the exact same light partner using visual blocks. Here's how to build it. In the Setup Initialization section, use the digital pin output block and repeat it for pins 2 through 9. Put them in the forever loop with weight 0.25. Add the when clicked command. After you select your board and click on the green flag, you should see the LEDs blinking on the breadboard. If you're working in Mind+, you can also find the complete block layout in the GitHub repo linked in the description. That's it for today's class. We covered the basic principles of electricity: voltage, current, and resistance. We learned about essential components like resistors, LEDs, jump wires, and breadboards. We built a real circuit using Ohm's law. This wraps up Module 1 of our Arduino for Beginners course. You now have the basic knowledge needed to understand any Arduino circuit. In the next module, you'll focus on programming and controlling your circuit with inputs like buttons and sensors. If you found this lesson helpful, please like, subscribe, and share it with someone who wants to learn electronics. This is just the beginning. Thanks for watching, and I'll see you in the next class.